Sorry. Did someone ask? Guys, and also, if I'm not audible to you, so yesterday I got an input from one of the attendees. Right? If my voice goes down, just let me know. Okay. Not audible. Okay. Let me increase my voice. Am I audible now?
Yes.
Is my voice clear?
Yeah.
Yes.
Yes,
Clear,
sir.
right? Okay. Okay, guys. Let us start with our today's session. And like yesterday we discussed, we're going to talk about. We'll see how to write an algorithm to find out the factorial of a given number. And also, like we discussed yesterday, what's a factorial? It's just a multiplication right away starting from the input, the number that we take in till 1. Okay. So I can write this in a reverse order. If I'm, example, if I want to find the fact of 10. So that will be 10 minus 1, 9, minus 1, 8, minus 1, 7. Okay, let's start this. 6, 5. And let me tell you one thing, why we are solving these algorithms is so that we'll get used to using the things like we have conditional statements, we have declarations, we have incrementation things, we have loops. So in our programming, these are basic fundamental things. We cannot write a program without these things. So why we are practicing algorithms is to get introduced to these things, so that when we actually write programs, okay, moderate level programs, it will be helpful to us. It's the only reason why we are practicing. Okay. So we have 5, then 4, minus 1, 3, 2, 1. And once we reach 1, we'll just stop our program. So whatever result we get, we'll add, put that into some variable and we'll display. So that will be 1 into 2, 2, 2, 3 is 6, 6, 4 is 24, 24 into 5 into 6 into 7, we will get some value. Okay. So the basic things we had done, a few steps I wrote here yesterday itself. So let us try writing the algorithm. If you guys have a pen and a paper or a book, if you're maintaining book and paper, or you are doing this in your laptops, you can also write alongside me. Let us begin an algorithm. Okay. So our first step is supposed to be start. Next what am I supposed to do? I'm supposed to read the input, right? First I need what number I need to find the factorial of. So we'll say read the input. No. Read the input number. Okay. Let's declare that as num. Next, step 3, we'll have a few declarations. Okay. We'll use the word declare itself. Read the input number and set it to num. We'll say something like this. Set it to num. So num will hold our input number. Inside next step, we'll declare a few variables. Okay. We need one variable to store our result, right? So let's call that as fact. Fact is factorial. Okay. And let's initialize it to 1. If our initial value is 1, because we cannot go beyond this. We cannot, because the fact of 1 is 1, right? So let us have it only for positive integers. So we'll initialize fact to 1, and we need to iterate, right? As you see here, we are going 1 decremented at each time. we have 10, we are starting with our num value. Okay, we can do vice versa. We can either start with the highest range or we can start with the lowest range. We can go from 1 to 5 or we can go from 5 to 1. It depends upon our algorithm. Both will work fine. Okay, so keep that in mind. Now we are declaring fact. Next, let us have an incremental variable. So in our previous sessions also I told you about iret. So we'll basically use it for incrementation variable. And let us go from 1 to low to high range. You can choose what you want to do. Okay. So I'm going from low to high. So I'll initiate I to 1. I'm declaring I and I'm initiating it to 1. See, there are two terms. Declaration is one term and initialization is other term. Okay. So when you talk about declaring a term, it's like you're not initializing things. You'll say like declare fact. That's it.
Okay.
Okay, and you will have a type of that variable. Type in the sense, is it an integer? Is it a string? String is like you have characters, right? A, B, C, D, and all. Character is single character. When you have more than one character, that comes up to be string. So, is it an integer or is it a double value? Double, whenever we have decimals, we use double. We use float. For integers, we use int. So when we write programs, we'll have to declare the type also. What type of a variable is it? Okay. For time being, we'll just ignore those types. So declaration is you'll only declare this is the variable. You're not initializing it to any value. Okay, that's only declaration. Initialization is you will initialize it to some value. You are declaring, and along with declaring, you are also initializing. Let fact be 1. Okay. When you declare, you will say like let us declare int I. Int is integer type. I is a variable. That's it. That is only declaration. When you initialize, you will say like int I is equal to 1. Okay. Int I is equal to 1. So the first declare fact, that is only declaration. But int I is equal to 1 is both declaration and initialization. Okay. Just keep this in mind. Okay. So we are initializing this to 1. Better we will use the term initialization. Initialize fact to 1. Integer I, incremental variable I to 1. And what will we do in it? Yeah, that's it. We'll do this in step 3. Next, what are we supposed to do now? We have factorial variable, we have incrementation I. Now we need to repeat things, right? To repeat, how far are we going to repeat? Is it going to be an infinite loop? And also see again, we have two terms here. One is finite loop and one thing is finite and the other thing is infinite. Can any one of you like explain or tell me what's the difference between finite and infinite?
Finite is loop which has a fixed number. Infinite has there is no end to the loop.
Yeah. So there's no end, right? So while we write our conditions or loops, that's actually correct. What we have to make sure is our loops are correct. Okay. At some point, at sometimes what will happen is we'll not at all enter into our loops. Okay. One scenario is this: we'll not at all enter into loops because our condition itself is wrong. And one more thing is, if we enter into the loop, will not come out of the loop itself. It will be running infinitely. It will be running infinitely. One example I'll give you. Okay. Let's suppose I have a condition. If I have declared I as 1, right? If I have a condition, if I is greater than 0, then print I. So now tell me what will be the output of this statement. If I have this, if I is greater than 0, I is initiated to 1. Okay. So 1 is greater than 0, I'll print 1. Right. In first step, I'll print 1. Next, what will I do? Again, I'll check the condition. Okay, print I, and then let me increment I.
I plus 1.
Increment I, which is I plus plus. Okay, we'll do this. So now I becomes 2. 2 again, it's greater than 0. So it will print 2. Will print 2. Will increment I. Again, it will print 3. As you see, the loop, it continues infinitely. We are not coming out of the loop itself. It will be running infinite times. So this is one thing, that is infinite loops. At some times, the condition will be false. It will never enter into the loop itself. One example is, I have declared I to 1, or to be more specific, I have initialized I to 1, and my condition is like I less than 0. Okay. Now when I start executing my algorithm, what will my algorithm do? Will check. First, I is initialized to 1. 1 is less than 0. Will I ever be able to print that value? No, right? Because we are not entering into the loop itself, or into the condition itself is false. So these are two possible things. One is we never enter itself. The other thing is we never come out. So we need to take care of those things. Okay. We need to know what the range should be, or how many times we need to repeat things. Repeat, the other word we can use it as iteration. Okay. Why I'm highlighting these words, we'll be using this frequently in a programming language. Declaration, initialization, iteration. Okay. So we'll be using this very often. Okay. So let's get back to our algorithm. Now what I've done is, we have initialized fact and we have I. Now I need to write a condition. Okay. So that until we'll have a range inside that condition, like from this to this, you keep executing. Once the condition fails, you come out and you do some other work. So what am I supposed to do? For fact of I, okay, I need to, since I've initialized I to 1, I'll go right away starting from 1 to 5. So 5 is basically what? 5 is my num, right? So my range should always be from 1 to num. Right? Range of what? Range of I. Are you guys getting this? Because we are using this I to repeat our statements, to repeat our work, or repeat our task. Okay. You guys getting it?
Yes, sir.
Okay. Yes. So now, tell me, what condition should I write here? The first I need to print is 1, right? Next I need to print 2, next I need to print 3. How we do multiplication, that is the other thing. But just
I into I plus 1.
Yeah, I into I plus 1. Now, that is secondary, what we do. I am talking about condition. For what
The
condition
number
should I do I into I plus 1?
That's it.
Let us use the word while. In our previous algorithms, we were using if statement, right? If else. So basically, that will be a while loop. Okay, I'll introduce you to this word here now itself, so that when we dive deep down into our program writing, there it will be useful. We'll be using while loop even here. Okay. We'll use while, or we can use for, yeah.
Why have you given the value for factorial as 1, like fact equals 1?
See, finding factorial values for negative numbers, that doesn't make sense, right? And fact of 0 is always 0. So you can have that in your one of your conditions. In initial steps of yours, you can have one condition. If num is 0, print 0. Right? That one
Yes,
condition
sir.
you can have.
Okay.
And also, when you're asking the user or to enter a number, also you can
Yes.
just make a note. You can just print or display some statements there. Enter a positive integer.
Yes, sir. Yes.
Okay, so that the guy will enter a positive number. If it's entering a negative number, for that also you can have a condition in our algorithm. If num is less than or equal to 0, you will
Yes, sir.
display a
Yes.
message to the user, sir, kindly enter a positive. So in that way we can handle things. So finding factor is only for positive integers.
Okay, sir. Thank you, sir.
In step 4, we'll have a while loop. Okay, so while some condition, do some things. Okay, while this is the condition, I'm going to write that condition now. While this condition, you perform certain things. Once you come, once the condition fails, you go out of this step. That is how we are going to write our step 4. Okay, main part of our algorithm is going to be step 4. Now let us write the condition. What is our condition? Okay, initial condition we have written. Initially we are starting with 1. We are starting with 1. What is the max value?
5.
5.
While
So,
I is less than or equal to 5.
yeah, while I is exactly less than or equal to 5. 5 is what? Which variable should I
Highest
use here?
value. 5.
Yeah, what is the variable for that? Num, right? We are taking it in a num, exactly. So that will be num. While I is less than or equal to num. And also, why am I using equal to sign here? Because I need to include 5 also,
5.
right? We'll have to include 5 also. That is why we are using equal to symbol here. So while I is less than or equal to num, do these things inside the while loop. What will I do? First thing is, as you see, we have this fact, right? So I'll use the same variable. Okay, fact will be equal to, we'll say fact itself into the value of I. Getting this thing, guys? Since we are using this variable, we'll store the values in this variable itself. So this gets updated whenever we come inside this condition. It won't be like fact will be again 1. No, we will be updating this fact number itself. Okay, that is why we are writing fact into I. Somebody told like it will be I into I plus 1. So that I is nothing but our fact. I plus 1 is the I itself. It will get iterated when we iterate it. We'll make I plus plus within the step 4 itself. We are doing 2 things. We are calculating fact and we are incrementing I. Okay, these are only 2 things we'll do. You're getting, guys? Is this clear? If you have any doubts, kindly ask.
No.
Okay. We'll do fact into I. Once we are done with this, we'll check again after executing I plus plus. We'll again go back to step 4 itself. Step 4 will be executed until and unless that condition is true. That is I less than or equal to num. Once it fails, it will automatically come down to step 5. Okay, that is the work of the while loop. When the condition fails, it automatically comes out of that. So once we come out of the loop, what are we supposed to do?
Print.
Yeah,
Print the output.
we are supposed to print. Print what? What's the variable that we have used?
Fact.
Fact, right? So we'll print fact. So we can use quotes here if required, but usually we don't use quotes. Quotes we use to get strings inside. And let just put a arrow. So we'll be printing fact. Finally, step 6 should be
No.
stop. So this is just simple, and this completes our algorithm. So the main logic is here in this step 4. We need to see what is the range or what is the condition until which we need to execute our stubs. That we'll get from like writing a few examples. Like we wrote for fact 5. We started from 1, we are going up to 5. So there's some multiplication operation that is being done. That we are doing here. That's in our hands, we can do that. For fact 10, it will start from 1 itself. We will go with 1, then we'll have increment I, it becomes 2, we'll increment I, it becomes 3, we'll increment I, it becomes 4, we'll increment I, it becomes 5, we'll increment I, it becomes 6, we'll increment I, it becomes 7, we'll increment I, it becomes 8, we'll increment I, it becomes 9, we'll increment I, it becomes 10. Finally, when it becomes 11, we'll just come out, right away starting from 1 to 10. That is 1 to num. 1 to num, right? So that is the condition. And what we do, we just multiply fact and I. I is getting multiplied with fact repeatedly. So that fact gets updated. Okay, so let's try an example. We'll we'll go iteration wise and we'll understand how our algorithm works. Okay. Let us write it for 4. Let us take num as 4. So help me out, guys. First step is we start the algorithm. Second, we read. So we have read the input. We are setting it to num. That is 4. Next, what are we supposed to do? We are supposed to initialize a few things. That is, fact is supposed to be 1 and I is, initially I is 1. This is our initialization part. Now we are going inside the condition. We'll see if I is less than or equal to num. What is I? I is 1. Is 1 less than 4? Let me write up here. Is 1 less than 4? Yes. So what we do? We go to step 4 and we'll update fact. Fact is equal to fact into I. So fact was initially it was 1 and it becomes 1 into I. I was 1. So this will be 1 into 1 is 1. So fact value is 1 at first iteration. Next, I'm incrementing I. I was initially 1. Now I will be, I becomes 2, right? Now check if 2 is, okay, oh, okay, now check if 2 is less than, is 2 less than 4? It's less than 4, right? Yes. So what we do? We'll update fact. Fact is equal to, what was fact in the previous step? It was 2. We'll
2,
multiply that with I. I was 2.
1.
I incremented, right? In the previous step, I got incremented.
Yeah.
So we'll have that I. So now we have 2 into 2, that is 4. Updated fact value is 4. Now we'll check if 4 is 4 less than 4. Is it less than 4? No, right? It's equal to 4. It is equal to 4, not less than 4. So what we'll do? We'll just print fact. So what was fact value? 4.
4.
Are we going right?
Sir, in this step, when you asked is 2 less than 4, is i's value incremented to 4?
Okay, our condition was less than or equal to, right?
Yeah.
So we'll do more. So the result is supposed to be 24, right? The result is supposed to be 24. Output is supposed to be something this, that is 24. Yeah. So let us see. First one is less than or equal to, so that will be fact into I1 into 1, that is 1. I is incremented, I becomes 2. 2 is less than or equal to 4, yes. Then we have fact 2 into 2, that is 4. We missed iterating I, right? So now I will be 3, right? So now I'll check if 3 is less than or equal to 4. Yes, it is less than or equal to 4. So what we'll do, we'll update fact. Fact is equal to its previous value was 4. And here in the first, fact value is 1, but we have taken 2 here, right? That's one mistake of us, which actually it has to be 1. Previously, what was fact value? 1. So we'll get that fact into, we'll multiply that with I. So 1 into 2 is 2. I incremented. Now previous fact value is 2. So take that 2, multiply that with I value. I was 3. So that will give me 6. I'm supposed to increment now. Just keep watching this. I'm supposed to increment I now. So I was 3. I will become 3 plus 1, 4.
4.
Now in our next step, we'll check if 4 is less than or equal to 4. It is not less than, but it is equal to 4. So even this condition is true. Okay. Instead of having true, yes, we'll have true, false, true, so that we'll use this. So this is true. So when it is true, you execute these two things. One thing is we increment update fact. So previously fact was 6. Fact will become fact into I. Fact is 6. I is 4. So 6 into 4 is 24. Now I becomes incremented. It becomes 5. We'll go to next iteration. Is 5 less than or equal to 4? Is it?
No.
No. So that is the condition fails. It is false. So we'll simply go to step 5 and we'll print fact value. So fact value is 24. So, and is it the desired output? Yes. Understood, right?
Yes,
Yes,
sir.
sir.
So we can try for one more example. Okay. So let us try for having number 6. You can just help me. Okay. So what am I supposed to write? You help me and I'll just enter things here. Our input number is 6. See the algorithm. What am I supposed to? First step I've done. I've read the input from the user and I've set it to none. What is the second thing I'll have to do?
Fact.
Okay. So tell that in terms of words. See step 3. What are we doing there? We are initializing something, right? We are initializing something. What are we initializing? We are initializing 2 variables. So one thing is fact and the other thing is I. Let me write that. Okay. So initialization is done. Next, what am I supposed to do? We'll go to step 4, right?
Yeah.
In step 4, we are checking something. Check if. What am I supposed to check?
I is less
I is less than or equal to none. What is I?
1.
I is 1. Less than or equal to num. What is num?
Num is 6.
Num is 6. Is this true? It is true. So if it is true, what I have to do? I'll have to execute step 4. Whatever I have within these statements. See, we have indentation here, right? I have not written this fact and I here itself. not started. I have left some space. What that means? When the condition is true, you execute whatever is within that. Okay. So this gives some high level, introduction to how the syntax is to be written. Okay, keep these things in mind. Whenever we have a condition, a while loop, there will be open and curly braces when you write proper syntax. Okay. So whatever we have within that, that will be executed. So when the condition is true, I have two things to do. Right. So I need to update fact and then increment it. So now what will I do? I'll have fact. Yeah, tell me guys, fact will be
1.
fact into I. Fact is 1 into 1. That will be 1. Next thing, what should I do?
I increment.
I plus plus, right? So that will be I was 1
1 plus 1.
plus
True.
1.
2.
That becomes 2. So I becomes 1 plus 1. Now again, I'll have to go check condition. So I'll repeat this. Now I'm checking for I, right? So I was
I is
2.
equal to
2 less than or equal to 6. True,
yes,
right?
true.
Now update fact. Fact
Fact
was
is 1.
and I
Is 2.
is 2. So 1 into
2 ones
2
are 2.
2. So now again increment I. I was
2. 2 plus 1 is 3.
2 plus 1 is.
3.
Let me repeat this again.
Picture.
Until and unless the condition fails, I'll have to do this. So we'll check for 3 now.
3.
3 is less than 6.
True.
It is 2.
Fact
So
is 2.
fact was 2 in the previous step. So I'll have fact as 2 into I.
3.
I is 3.
3.
2 times 3 is
2 3s are 6.
Then
I is
we'll
equal to
increment.
3.
I was 3.
3 plus 1 is equal to 4.
3 plus 1 becomes 4. Right? So next,
That's
again,
it.
I'll have to check condition.
4.
Is 4. It is true.
True. Fact is equal
Fact.
to
What
6.
was fact?
6.
Fact was 6.
So,
And I is 4.
6 3s are. Oh.
I is 4. I incremented
Yes,
it.
yes.
So that's 24. Okay. Next step is
4
increment.
plus
I
1
was
is
4.
equal to 5.
5. Next, again, we have to do.
Check.
2 becomes
It's 5.
5.
It's
It
true.
was 24.
24 into 4.
So I is incremented to 5. And 24 times 5 is
120.
5. 10 times is 50. 20 times is 100. And 4 is 20. So that is 120, right?
Okay.
Next, I'm supposed to increment I. That becomes 5 plus 1.
6.
Then check the condition. Check if 6 is less than or equal to 6.
Yes, 6 is equal, 6 equal to 6.
It is not less than to 6, but it is equal to 6.
Equal to 6, it's
The
true.
condition is true. So what we had in our
120
fact value, it was 120
into 6.
into 6. So what it is
6.
supposed to be 612 times. 6 10 times is 60. 2 times is 12. 60 plus
72. 72 plus
Add 1 0.
720.
So that is 720.
720.
Increment I. I was
6 plus 1 is equal to
plus
7.
1. So now it's 7. Now again, I'll have to go inside. I'll check the condition. I'll check if 7 is less than or equal to 6.
False.
It becomes false. So when it becomes false, I'll only
Print the 5.
go to step 5.
Step
Right?
5. Step
We'll
5
go
is
to step
print the
5.
5.
We'll print fact value. Print fact. That will be 720.
20.
Got it?
Yes, sir.
It's a simple algorithm, right? So when you do things in this manner, then actually step by step, when you iterate and do things, you'll understand the algorithm much more easily. So there's nothing much in the algorithm. The start step, the stop step, it always remains same. And reading the input, it depends upon what algorithm and what input it is supposed to be. So based on that, we'll write a simple statement to take the input. if we are having write an algorithm to add three numbers, so the input statement will be read three numbers, right? And at the time of
Yes.
initialization, whatever three numbers the user
A
enters,
plus B plus
store
C.
that in three variables, three separate variables.
Yes.
So initialize A to first entered number, B to second entered number, C to third entered number. That is initialization. That is also okay done. And lastly, we'll have to display something, right? We'll have to display the output. That step will also be used finally stop. The main core thing is the logic that we write. Right. So here it's step 4. So whenever you write an algorithm or you try to write a program to find the factorial, just remember this logic. How many times do we have to repeat things, and what are the things we need to do when the condition is true? We need to keep updating fact value and iterating. So when you use while loop, this is the way how you do it. Let me show you using the for loop also. Okay. So while loop, for loop, don't get confused. We use these loops only for iterating things. Just keep that as simple. Okay. When you want to repeat some things, you use loops. So while loop, that is also, you can use while loop, you can use for loop. It depends upon things. Whenever we don't, both are, you can use both loops. There is no hard and fast rule that you cannot use while or you cannot use for. It depends upon you. Whatever suits you, whatever condition loop statements you are familiar with or it is easy to you can use that. So we have written an algorithm using while loop. In while loop, what we do, first step is you initialize. Step number 3, right? You see that, guys? Also, you can make a note of this somewhere. Okay, you can make a note of this. When we are writing a while loop, the syntax it is supposed to be, first thing is we initialize. Okay, we initialize variable. You can see we are initializing I to some value. Okay, initialization is first step. Second step is we check the condition. In step number 4, the first thing what we are doing, while I is less than or equal to, you check the condition. If the check, so the output will be like the condition will either be true or it will be false. You need to know when it is true what you need to do, when it is false what you need to do. So when the condition is true, we are getting inside that loop and we have two things there, two lines. That is fact is equal to fact into I and I plus plus. That is when the condition is true. Once the condition fails, you just come out and you do some steps. That is print. You're printing the fact. So first step is initialization. Second step is condition. And the increment part, we can write that in next step also. Okay, it's according to our convenience. You can write step 5 is equal to increment I. That can also be that one thing. So with while loop, you first initialize, you have condition and you have I plus plus. That is incrementation. Now what we are writing is for loop. When you use for loop, all these things will come in one thing, one statement or one line itself. Okay, so let's do that. We'll just modify this. We'll write the same thing. We'll initialize only fact here. Okay. Let us just modify it a little. So we'll use for. Okay. So whenever you're using a for statement, there are 3 things you need to make note of. Okay. It will be something like this. Okay. Whenever is this condition is true, we will have statement 1. Guys, I'm audible, right?
Yes.
Yes, sir.
Okay. So we'll have statement 1, statement 2, statement 3. Okay. And similarly, we'll have n number of statements. Okay, it depends upon what we are writing. So this will be the syntax for a for loop. So whenever this condition is true, you will come within this loop, and whatever is inside this loop, you will execute those things. Statement 1 will be executed, then statement 2, then 3. Okay. Statement can be anything. It can be any logical operation, or it can be anything. It can be any display statement. You're printing something, or whatever. It's all logic. Okay. So, and the final thing is what we have inside the for loop. First thing you do here is you do initialization. initialize. Okay, initialize a variable. Let us suppose usually we take that as I. Okay, when we have only one thing, we'll have one directional. Okay, at that time usually we use I. Okay, and then we'll have a semicolon. We initialize, then we'll have the condition in between. Okay, until what condition should this loop be iterated or repeated, and finally the third part, that is incrementation or decrementation. We either increment I, okay, increment or decrement I. Two possibilities. We can do either of things. We can either increment or we can decrement. Got this, guys? So this is the syntax for your for loop. What we did here, initialization of I, that we are doing it here. Second thing, what we have here, the condition in while, that condition will be written here. And what we are doing here, before ending while loop, what we are doing here, the incrementation, that we'll do here. So in one single line itself, it checks for all three things. So we'll initialize I to 1. This part, we are writing it here. Okay, no need to write this initialize. Okay, this is just for your understanding. Condition, what was our condition? It was this, right? So let me copy that and we'll have it. But just to make you understand, I'll have this. This is condition. Okay, that will be I less than or equal to. Then increment or decrement. So this will be same. Third thing is increment or decrement. So in our program, we are doing incrementation. So that will be I plus plus. Right. And what are the things that we are doing inside it? It's the same, except for incrementation part. It's only one single line. Okay. We'll do fact is equal to fact into I. Right. So let us replace things. This is your actual for loop. Okay. We'll have it here. Let me just see. I'm making sure of the indentation. You need to see that. If I write fact here, that is not the correct way. It should be inside this part. Okay. You can have this curly braces. So that will be your for condition. It will keep repeating. Okay. Once the condition fails, it will automatically come out, and this remains in this two steps remains. Only this part changes. Only step 3 and 4 only this initialization of this iterable variable I, and this condition and this incrementation is changed. So this is the syntax for using a for loop. First thing, you initialize. You will check for condition until when. Okay, this condition should be run. Like when it is true, what should you do? If that condition you write here. Finally, you increment or you decrement I. Because if you don't increment or decrement, so how will we again come back to the loop? Or what will we do? If you don't increment, I will always remain I. Initially, I is 1, right? So when you come back, again I will be 1. You check the condition, even though your condition is correct, you are not incrementing or decrementing it, I still remains 1. So every time you come back, that will be 1. This will also lead for finite loop or infinite loop.
Finite.
Finite, huh?
So we have to give the number.
Infinite, right? See, if I don't have, even though I don't have this thing, right? Even I skip this, my program will run or my algorithm will run. Okay, even if I don't have, if I only have this semicolon and I have nothing after that, it will run. But the thing is, what will happen to the program? See, I'm not incrementing. First time I initialize 1. 1 is less than 5. Yes, you get inside, you do this. Again, next time when you come back, again I is 1 itself. So again it will, like do 1 into 1. So it keeps repeating. It will not come to an end. So for that reason, we have to do either incrementation or decrement. It depends upon what we do, either increment or decrement. Understood, guys? I hope you got it.
Yes, sir.
So this is for loop syntax. While loop syntax is, first thing is you initialize. You use the keyword while. Make a note of this also. For while loops, the keyword is while. For loops, the keyword is for. Okay. And here even here you will have curly braces, just for your understanding. You need not remember this now when we actually start writing syntax and all. At that time, this will be useful. But in the early stages, just have a look at it. Just have a look at it so that you will remember when we start the things. You will just have this in mind. So we'll have while keyword within this parenthesis. Okay. These are not to be, you cannot write curly brace or square bracket here. You will have to use this parenthesis itself. So remember that thing.
Sir, how do we know if it's a while loop or not?
See, that is what I'm telling. See, based on what you write, the syntax you use, that will define what loop you're using. Okay, if you use keyword as while, it itself says that you're using a while loop. If you're using the keyword for, that will say that it is for loop. And as far as the thing is concerned, like which loop you need to use, it depends upon your convenience. Now see, our algorithm is written in both. If you execute both the algorithms, you will get the result as expected. You will get the same result even here. Okay, it's just the thing like you are using two different loops. Okay, at some points we use while loop, at some times we use for loop. When do we
Both
not
are-
use for loop? Okay, when do we not use for loop? At times, what happens is we don't need incrementation things. In our previous examples, as you can see here, we are not using any iterations here. We are only checking, we are starting the number from 1, 2, 3, 4, 5. Until and unless the number becomes 0, we'll have to execute. So at this place, we cannot use for loop. Even though we can use for loop, this part will be empty. But the condition will be like num not less than 0 and will not have this I iteration variable also. We'll have one simple condition, direct condition without iterations. So at that time you can use I. At that time you can use your while loop. So this can be replaced as this piece of code. This can be replaced. We can use a while loop here. We are setting reverse instead of using while. If what we'll do is we'll write while num is greater than 0, no writings going to step 4 or no writing else go to step 5. We'll get inside this while loop. We'll perform these three things. Okay. We'll perform these three things. We'll find the reminder. We'll update reverse. And finally, before ending the coming out of the, before going back to the condition, we'll reduce the number. We'll divide num by 10. This part. First this, then this, then this, then this. So that part we'll do. And finally, we'll print reverse. So when will this? Okay, let me remove this word also. You'll have reverse is equal to this reminder, reverse, and now finally we'll print reverse. When will we print reverse? We'll print reverse. Acha, I updated the wrong. When will we print reverse? Let me remove this step. We'll prevent reverse once this condition fails. Automatically will come to next step. Okay, so that will be step 4. We are missing start and stop, but that's okay. Okay, you get the input number, you set reverse to 0, can check the condition. If num is greater than 0, first time 1, 2, 3, 4, 5 is greater than 0, yes, you do these three things. Then again you go back, you check. You will be within the loop itself until and unless this condition is satisfied. Finally, when num becomes 0, at the last iteration, when it becomes 0, 0 is not greater than 0. So you will come out, you will print reverse. Reverse will be 5, 4, 3, 2, 1. Okay. So this is how your algorithm will look like when you use a while loop. Right. So you'll have while statement, you'll have curly braces, you'll have condition inside you. This is the syntax that I'm writing in here. You will have two curly braces, and inside this you will have statement 1 to statement, let's say n statement, n number of statements. Just have a look at this semicolon also. Whenever you end a statement, always you should have end that with a semicolon. Whenever you write a line, that should end with a semicolon. Okay, these are things that I'm telling you now, so that in next coming sessions we'll start with Java syntax and already basics, so that will be useful. This is how your while loop will look like. And as far as your for loop is concerned, you will use keyword as for. And one thing I did not write here, you need to initial. That's okay. At times you initialize variable. Whenever you have iterations, you will initialize I, and before coming out, you will increment I, just like what we have done here. Because we are using I here, we need iterations. We need to increment I. That is why first you initialize, check for the condition, execute the statements, and before coming out, you increment. If it is not that way, it is just like this. If it is not incrementation part, you just check only one condition. Until and unless that condition is true, you keep executing, or else you come out. So that is how while loop looks like. For loop, you will have keyword for, you have these braces, parentheses. First thing is you will initialize. Let's say we are using term as I to anything. For example, I'll write it as 1. Okay, you can initialize it to anything. Next, you check the condition. Okay, so since it is just initialize. Second thing is condition. Okay, the third thing is
Incrementing.
either increment.
So how do you use the for loop for the step 3 instead of while?
Which one?
Is it possible to use for loop for the third step?
Here,
Yes.
yeah, you can do that. Okay, here you will have your statements, n number of statements. This is how your for loop looks like. Now let us try writing this for using a for loop. Using while loop, using for loop. You can understand it, right? With the word loop itself, that should come into your mind. Loop is nothing but we are iterating, we are repeating things. It keeps repeating. It's just a kind of a circle. You keep repeating things. So the loop itself highlights what we are supposed to do. So using for loop. Okay. For loop, what we'll do, we have no iterations here, right? So what we'll do, first thing is we'll have for as the keyword. Second thing is initialize. We are not initializing anything, right? Are we? No. So we'll just put a colon. We are not initializing. Condition remains same. Okay, condition remains same. Then again, we'll have this increment or decrement part. We don't have incrementation or decrementation part here. But one thing we can do is this. You see this step? This is repeating, right? Every time before you go to next condition or next iteration, before doing that, you need to reduce your num. Num becomes number 10. This part you can add here. You can remove this from here and you can put it. You can put it inside this thing. Okay. So num will be num plus 1. Num is equal to num plus 1. Just need to check, okay, if this works out. We'll see. Else, if you know if this is pretty much confusing, we'll just keep it here itself. Okay, so this is, there is, as you see, it is not much of a use of using for loop here. Like there's no incrementation stuff. Even though you can execute the program, but that does not make any sense of using for loop here. So the better thing is using while loop. I hope it cleared your doubt.
Thank you, sir.
So we'll just do this. Put this here. So using while loop syntax. Syntax is this. Okay, this is the syntax, and you are using that syntax. Okay, we are using the while loop in our algorithm. I know we are missing step start and stop here. You can complete that. So algorithm will be this. Next, okay, just remove these things. I'll like maintain this thing. At the end, I'll share this text file itself to you guys in the group, so that this will be saved. You can anytime you can go back and you can check this file. Okay, we'll refer to this itself when we execute programs. For each algorithm we are writing here, we'll write a program and it will execute that also. So that we'll refer to this text file itself. Okay, using for loop with that. For loop, yeah, the for loop is for loop. I'll remove this algorithm, okay, factorial using while loop, so that the previous algorithm is solved using while loop. This algorithm it has solved it with using for loop, so that both the loops will be covered. There is one more loop, that is do while loop. Okay, that is just a modification of while loop. While this is the condition, you do this. That is how it means. But usually that third type of loop is not used very often. Okay, either while loop or it's for loop. Using for loop. This is your syntax. Guys, did Abdul sir take algorithms on writing algorithms for different patterns? Have you guys done that? He actually, as far as I remember, he had a few print patterns as assignments to use this, right? To write algorithms to those patterns, star patterns, number patterns. Did you guys do that? Or
Yes.
Sorry, can
we'll
you repeat?
continue that? Okay, let us add that into our algorithms. We'll solve a few star patterns also. Okay, syntax for loop. Example using for loop. This is our algorithm. Okay. I hope this file will be helpful to you also. Okay, making things clear here. So this is the algorithm, and then we have solved two examples. Okay, this completes our algorithm. You guys understood this?
Yes, sir.
Along with solving the algorithm, we also understood a few basics, right? with respect to conditions, loops, with respect to loops, with respect to declaration, initialization, what is finite and what is infinite, right? And the syntax also, we learned the syntax, 50-60% of the syntax, initialization, declaration, loops, conditions also, we came across conditions also, like if condition, if this is the condition, you do this, else you do that. That is conditional statements. If true, you do this. If it is not true, you do that. If else statements. Those are called if else statements. Okay, those are conditional statements and these are loop statements. So we have covered these things. As in, like we are covering the basics here itself. Declaration, initialization. We talked about types also, right? Data types, integer, string, character, float. These are nothing but different data types, basic data types. We'll come across this when we start in Java. Okay. Guys, I think we can end the session, but before we do that, tomorrow, let me give you an update. I won't be able to take class tomorrow. Okay. So even Abdul sir isn't available. One thing you can do is, I'll give you an assignment, but I want you guys to come out the next time when we meet. I want your response on it. Okay. You need to work this out. Try writing a algorithm and understand what it is. Algorithm to list, you can say list, or to give out to display the output. Fibonacci series. Algorithm for Fibonacci.
Okay, sir.
Just a second. Fibonacci series. So just have a look at what is Fibonacci series and try writing an algorithm to that. And again, do not refer internet or YouTube and things. Just you refer what a Fibonacci series is. I'll tell you that here itself. You can only refer. A Fibonacci series is it either starts with 0 or 1. It depends. Okay, it either starts with 0 or it starts with 1. Then before we start Java, yeah, we'll do that. We'll do that before we start. We'll do that. Okay, Fibonacci series is it either starts with 0 or 1. Basically, most often it starts with 0. Okay. Next, what we do is we'll have 1 here. These are basically by default this will be present. Okay. If you are supposed to write a Fibonacci series, 0 and 1 will always be there. Next, first we take an input. Let's suppose we need a Fibonacci for num is equal to 5. 5, the length of 5, we should have 5 digits having the Fibonacci series. Fibonacci series, it goes on. It depends upon how much of the series we want. We want 4 numbers, 5 numbers, 10 numbers. And that will define here. We'll take the input as 5. So we'll have 0, 1. So these two by default will have. Okay. So addition of these two will be the third term. So what will be 0 plus 1?
1.
1. Next, the addition of the last two things now. What are the last two numbers? 1 and 1, right? So addition of 1 plus 1. 2. One more thing. Again, one more iteration. 2 plus 1. 3. Okay. So see, we have covered 5 numbers already. We'll not go inside the conditions again. I'm telling you about the conditions also, how it goes. We took input as 5 and we are printing 5 numbers from Fibonacci series. This is how the Fibonacci series goes. Okay. Basically, it will be 3. Next, 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, so
13,
that's 13. 13 plus 8 is 21. Okay.
21.
This is how it keeps going. This is the Fibonacci series. So, what I want you to write is like write an algorithm for a given number. Algorithm for Fibonacci series. Algorithm to print Fibonacci series for a given input number. If you say the input number is 5, you just print first 5 numbers. If it is 6, you print until 5. If it is 7, you print until 8. If it is the 8, you print until 12. And if it is 10, you print until 12. It will go like this, okay? But the Fibonacci series is something like this. It looks something like this. By default, you will have 0 and 1, and further it keeps incrementing. You add the previous 2 numbers and you keep going forward until and unless you reach the length of your number. Okay, so this is your Fibonacci series. Try writing an algorithm, understand what Fibonacci series is, and try writing an algorithm to achieve this. Okay, next class when we meet, we'll work on this. And tomorrow we don't have a class. Okay, maybe Monday, I'll see you guys. We'll meet again and we'll continue our things. So this is one thing. The other thing is try writing algorithms for patterns. Okay.
Okay.
Since you will have 3 days break and giving you a few assignments, kindly do that. Patterns.
Okay.
The first pattern will be star. Stars. 3 stars. Again, this depends upon what input you are given. Okay, if your input number is 4, so it will only print 4 lines. If your input number is 5, then you will print 5 stars. So this is one pattern. Next pattern will be 1. Okay, if your input number is 5, it will be first. It will be 1, 2, 3, 4, 5. You should have 5 lines. It depends upon your input. Third and the last is it's the same thing, just slight change you need to have. 1,
2, 3, 4, 5, 6,
5,
7, 8, 9, 10.
3, 4 lines. You will not have like you won't be able to identify them, but let it be 10, 11, again 12, 13, 14. What would you okay? One number at a time. 7, 8, 10, 11, 12, 13. In second line, it will print 2, 3. Third line, it will print 3 numbers. Fourth line, it will print 4 numbers. Okay. Then this will go down. Okay. 10 ka 1 will be here, 0 will go down. Okay, it will be something like this. Next 11 and then 12. 11, something like this. Okay. Try figuring out algorithms, use your logic. And we'll get back when we get back on Monday, we'll discuss on these two things. Okay, guys.
Okay.
We'll end this session. Yes.
Yes, sir. Thank you.
Okay, thank you for your cooperation. That's great only.
Thank
Take care,
you.
guys. Okay, take care.